This is the second presentation for today's GS UK conference, virtual conference. And my name is Anna Dawson. And it's very slow to advance the screens. There we go. I have worked for IBM since 1997. I came as an experienced hire on OPC or whatever else you know it as. My day job is taking people from other scheduling products to IzWS and pretty much anything anybody wants to know about IzWS. This particular session came about because I was asked to create it. I was asked to create it for the US IzWS conference that is occurring in 3 weeks' time. I have still to talk to the organizer to see exactly what he wanted me to do, but I have put this together and you are the first to see it. And really it's talking about all the different dependency types you might have in IzWS and maybe point out some reasons why you might choose to use those. So what is a dependency? Well, the standard dependency, the one that everybody knows, is another operation, but it's really anything that needs to have happened before something else can happen. Okay, so as I said, normal predecessors, operation predecessors within the within your controller, and there are different ways to define those dependencies. Job dependencies, closest preceding, that's the one we all know and love. That's been around for well, 30 odd years more, but that's been changed. So now we can also say we want to be dependent on something that's going to happen the same day or in a relative or absolute time period. We've got conditional dependencies, shadow jobs, external jobs that you could be waiting for. But waiting is the appropriate word, I guess. If a job is in W status, waiting status, then there is still some type of predecessor operation that has not yet been completed. But when the job has moved from waiting status to ready status, it can still not run. It can wait for other things like time, special resources, workstation availability, and other things. Okay, so I have attempted to create one screen, one slide for each of these different possibilities. And you can unmute yourself if you want to ask a question, because each slide is about a completely different type of dependency, and therefore it may be more awkward to leave questions to the end. So it's entirely up to you. You can still put things in the chat. I can see the chat if necessary. Okay, so our standard thing, a predecessor job, and the usual rules, of course, applied. It would be closest preceding, which means that the input arrival time of the successor operation must be the same or greater than the input arrival time of the occurrence that contains the predecessor operation. And all of those types of dependencies are built when the long-term plan is created or extended. And they're external dependencies, but of course there could be internal dependencies because they're operations that run in the same application. So here I just have an example of building a dependency. it's for the operation. You select number one from the menu of different things that you can add to an operation. And number one is dependencies. And you can put internal and external ones. An external dependency must have an application telling you which, and in this case, it's the same application. So we're basically saying we're waiting for this to happen in the previous occurrence of this application. But from this panel, you can also see that you can set up your conditional dependencies, and you can also change your dependency resolution criteria for other processes, other ways of creating the dependency, or rather not creating the dependency, but finding the dependency. So dependency resolution, as I said, closest preceding is the default or the common or the historic way of doing things. But now you have another option. You can say that the resolution is mandatory. That is, it must be able to make it. And although this one says no, it could say P or it could say C. P means that when the current plan is built, it must be able to resolve that dependency. And if it can't, the current plan extend will fail. And you'll get messages to tell you that. I personally have never used planned. For me, it feels a little dangerous. So I generally use C, which just means that it can come along later. Okay. And that means that it could be something that's going to be added dynamically, like an ETT, or it's going to come in with the next current plan extend. It's just that it's not there now. Closest preceding, as I said, that's the default here, but you could have same scheduled date. So the scheduled date in a normal calendar is from midnight to midnight. So you could be waiting for something, you could say same day. It may have come in earlier, or it may be about to come in. It does mean that the input arrival time of the application with the predecessor in it can be later than the operation that's waiting for it. So the chronologic order of occurrences just went out of the window. And it will look back within this day for the predecessor. And if it can't find it in a previous occurrence, it will look forward for it. So that can be useful. But most of our batch runs across midnight. So actually, if you want to use that, you may want to set up a different calendar that runs from, say, 8 in the morning to 8 the following morning. That really does play with your head a little bit when you want to set up your applications, because then 8 o'clock on, let's say 7 o'clock on a Tuesday morning is actually scheduled for 7 o'clock on Wednesday morning in the reality of time. So useful, but perhaps one to do some testing with first. Your other option are within a specific interval, either a relative interval or an absolute interval. The difference between them is you are saying what period of time you can look for the predecessor in. So, if you have, say, a repeating job, and it's only the one at 5 o'clock that wants to wait for something, then you can use the before and after to say maybe 2 hours you want to look back before your successor's input arrival time to 2 hours after your successor's input arrival time. All of these are relative to the successor's input arrival time, the job that's waiting for its predecessor. How far can it look back? And this one is when you have a time when you expect it to happen. So within an absolute interval, you'll say from a specific time, and then how many days. So you could be looking for something 5 days before, I don't know, or 3 days after. So you could put that here. That's your absolute interval. It is a way to solve problems where you've suddenly got an input arrival time that is later, and it's not a problem until you add this other job in, which now is now a predecessor to something in an earlier application. There are other ways you can do it. We all know that we can put an operation input arrival time on the job, but this gives you additional options now. Conditional dependencies. The example I've got on here is just a simple one. So I'm going to wait to make sure that my return code was 8 on a particular job and a particular step, in fact. And this a step dependency, the little bit of a cheat here. If you have a long running job, you can say you're only dependent on a certain step from that job. And then assuming it meets the criteria, your successor job can start running, even though the predecessor job is not yet complete. Also, you can have a whole load of conditional dependencies. So you might have a job that is waiting for a predecessor, which is going to run when the data becomes available. Or you could also say, but if it gets to 3 o'clock, I want it to run anyway. So you could have 2 predecessors. One predecessor is the real job that may or may not run before this job is scheduled to run. And another one that has a time dependency on it of, I don't know, 3 o'clock in the morning. And you can say only one of these needs to be true. This is certainly something that I know we all used to build based on the original way that you could do things. We would have said that a job is dependent on a timed operation or a real job. And if it got to the time job would remove the dependency or whatever it was so that that job could run. And if the actual job ran, then that would also have a step after it that would get rid of the timed operation. Now you don't necessarily need to do that. You can just list them both and say that you can run if one of those 2 dependencies is okay. The other for this is that you can say if this job completes, for example, or if this job goes in error, you can take a different path through the code. So you can say if a particular job fails in a particular way, then the jobs that are going to run after it, it might run leg ABC, or it might run leg DEF. And the opposite leg will be treated as if it was complete. Okay, it will get a status of X. So this is another very useful way that you can work with dependencies and deal with situations that your applications people ask you to deal with. Of course, you also have auto recovery, which is another way that you could fix this particular situation. But of course, any new stuff that you do now, you could use this way of solving the issues that you have. And I'm sure you can think of many other ways that you can use a conditional dependency. Cross dependencies, shadow jobs, also known as. So a shadow job is a job you build in your controller that is shadowing the job or an activity in another controller, or master, a distributed master. So what I have here is what you have to do to be able to use shadow jobs. You need to have a workstation that is representing the master or the controller in another environment. And you need to say that it's a remote workstation, so it won't try to run anything. A remote workstation. You need to say server usage is none, because there is no servers there. It's not running anything. It's just watching for something on another system. And you have to say what type of remote engine it is, whether this workstation is shadowing another controller, so it would be Z, or it would be a D if it was shadowing a distributed master. And in order to be able to do that, you have to define the destination. So in the parameters for IzWS, you would have a root-op statement using HTTPS and providing a destination name, the IP address, port, and also on the end it would be a Z for a Z remote. And here you can see in the destination we have that particular destination named down here. So all of this must match up, and then the job that you define on this workstation should be the same name as the job in the other environment, and they will do something called a bind. So when you run the current plan extend or whatever, it will try to bind with the operation in the other environment. There have been some problems with that, I'm not going to lie. And that has actually, I think there was an SPE that came out, we're in May, last month, April. And that had was providing better control over this particular element or process that you can use. Okay. Externally submitted jobs. So one example of this might be something like kicks. At the end of the processing for kicks for that particular day, there could be a process within the Kix environment that submits a job. Here I've called it Kix 5 end of day, EOD. And the submit flag has been set to N instead of Y. And that means that IzWS knows it doesn't actually submit to this job, so it's going to be looking to track it from outside. And that has some interesting things, because the job coming out of Kix could be just an FBR 14. It doesn't do anything. It's just saying, yep, we are ready to run the batch that needs this Kix region to have, finished for today, whatever that means. And the job name would be tracked, and that would be all we needed. That would be that particular dependency ticked off. However, you could be submitting the jobs, real jobs that are going to do lots of stuff, and submit them as type run equals hold. If you do that, IzWS will take control of those jobs. So, and you can have other criteria defined on the operation that would prevent the job from running until such a time that you wanted it to. So, for example, where I worked, we have a piece of software that would, when it determined that a disk required defragging, then it would automatically issue a job onto the system to do that. But if those disks were part of your online day environment, you didn't really want to be running a defrag whilst your system was needing those disks. So although it would submit the job, we had altered the skeleton for the job that was being submitted to have a type run equals hold on it. And all the jobs would come in with the same job name, basically. But they would have within them the information that said about which disk it was and so on. But we didn't want them to run yet. So in the definition for those jobs, we gave them a special resource. And that special resource was only available, and we had the interval set up, so it was only available between the hours of 10 p.m. and 6 a.m. And then we also said, and there was just a quantity of 5. So what that meant was that when these jobs were being submitted by the software that was looking after the disks, it would keep hold of that. It would leave it on the JES queue. But when 10 p.m. came along, it would allow, it would do a release on those jobs on JES, 5 of them, because it, 5 special resources, 5 of the resource that they wanted. And then as each one of them finished, it would release another one from the JES queue. So that was a reasonable way of dealing with those, still getting them run that day, so they were defragged before the next morning, but not overloading the system with those jobs. And that can be useful if you have a lot of jobs coming in. It can be a way to take control of those and make sure that they run as you need them to run. So those are all the things that, where the predecessor job or the job is in waiting status, or, well, in fact, for the externals, they would be in ready status once the job had arrived. Okay, but time. So time is something that, even though the job has completed all its predecessors, it is ready to run, but is being held up by some other activity. So time is one of those. It's actually on the one over here, flag to say whether an operation is time dependent. But then all the information about the time is actually in the time panel. And so we have an input arrival time here of 9 o'clock, and excuse me, it is time dependent, and it will be released at 9 o'clock. But there are other things that you can do with the time panel now. So relatively new is the fact that you can say that if the job hasn't started by a particular time, or if if it hasn't started by a particular time, it can send out an alert. You can also say if by a particular time it hasn't started, then you would do an action, and you could force the job to go complete when the specific time is reached. This one's also a nice little panel that allows you to define that the duration time of the job in certain instances is longer or shorter than the normal run. So using the row command down here, you can say that if the application run cycle, oh, sorry, I was doing that a lot yesterday. If the application run cycle or a run cycle group is active today, so you build some run cycle groups that are for specific purposes, you can change the estimated duration of the job. And it will be managed by IzWS separately to the default time. So if you had a run cycle for the last working day of the month, and you know the job runs much longer, you would put in a duration time that was longer, so maybe 2 hours instead of 1 hour. You could set a different deadline time for it if today was, say, a Saturday, so it's not so important that the job completes by the time that you usually have as a deadline. You can also say that on those particular ones you're going to knock it or manually hold it, or you can have a different criticality indicator. Okay? And you can also change what time your not started alert or your not started action takes place, because maybe if it's the first day of the month, you're still doing all your end of month processing, the times when things should have run by will be different, and so you don't want to take action quite as early as you would have done previously. Okay, so this allows you to be a little bit more flexible with your alerting and duration and so on, which help with the whole critical path setup. The next one that I have here is workstations. Workstations have assigned to them a number of parallel servers, and those parallel servers can be available all day at the standard setting, or you may have said that on certain days the number of parallel servers increases or decreases. So perhaps on a production system that is online heavy, you may only allow 5 parallel servers for batch jobs during the day, and whoosh that up to a much larger number when the online day window, where you have to have a lot of availability, drops down so that you can have more batch jobs running. So you can use workstations to restrict the number of jobs that are running, and that's really what it is when you put dependencies onto jobs that would be in ready status and have no other reason not to be submitted. You do R, I think, for resources, or A for availability. I can never remember which one. I should have checked that before I put that screen there. But you can set the periods of time when the workstation is available or not available. And your server usage must be either control or both. If you use none or just planning, then although you might have set it to just 5 parallel servers being available during the day, if we're not tracking parallel server usage, then that's pointless. It will still submit more jobs than you want it to. Oh, and yes, it is possible. I don't see it done. I've not heard of anybody doing it for a while, but I guess there may be the occasional thing. You can close all workstations, if there's a reason that you need to stop running batch for a period of time. Used to be that you'd do it for Christmas Day. There shouldn't be anything that ran Christmas Day. So you would just hold everything up wherever it got to on Christmas Eve, and then carry it on Boxing Day or something to enable everybody to have the day off. But companies aren't that generous anymore. Let's see what's next. Special resources, everybody's favorite. If you can't do it any other way, a special resource will solve your problem. That's what I always like to think. So again, you can have intervals when they're available and unavailable. You can say which workstation they're specifically connected to, so it doesn't affect all the batch. Here we've got a special resource called class H. Maybe we have an initiator class H that we can only allow 10 jobs to run in parallel because there's only 10 initiators for class H. And so this will ensure that we don't throw too many in and that IzWS remains in control of the jobs rather than leaving it to Jez to decide which job it wants to run. If you throw 100 jobs in, but only 10 can run at once because you've only got 10 H initiators, because something else that wants H may come along that is far more important than those jobs. And on a FIFO, first in, first out, Jez could hold that job up for hours. Whereas if you don't have too many in there, the next one in would be the one that was most urgent, decided by IzWS. So it is good to be able to mimic your entire environment using something like special resources. And especially now with special, well, not just now, but always, just have it set for control. Don't set it for planning. When you do your current plan, it extends. If the resource is generally unavailable, IzWS won't know when it's going to become available. So those jobs that want to use that special resource will be put to the end of the planning period, which is 8 days into the future. So to avoid that, only have it on control if it's possible that by default the special resource could be unavailable. You can say what should happen to the resource on error. There'll normally be a setting that you've created for your default action, but you can say if the job ends in error, you can free the resource so other jobs can use it. You can free it if it was shared. You can free it if it was exclusive, or you can keep it. So if it was a job that was doing something quite drastic to a DB2 database, for example, and it had exclusive use of the special resource, then by using this, you could prevent other jobs if it failed trying to use that DB2 database. And you'd keep it so that there's no chance of something using what could possibly be a corrupt database. When the job that's using the resource has completed, you can say whether the resource should now be left as available, not available, or you can leave it blank and it will pick up a default, or reset to what its default value should be. And a max usage, you can say how many times the resource can be used before it becomes unavailable from when it was available. Oh, I should turn off that pad at the bottom. Yeah, and you can say what type of usage it was for that. Dataset triggering special resources, the two of those together. Of course, you can have a special resource representing a dataset. If you add it to the EQQ LSENT table, which is a table that's associated with tracker, this is the job from the IzWS sample library to build that table. You can look for data sets being closed that match the string that you put here. If you leave a space, then you've said that this is a, I always get this the wrong way around. You can say that it's a data set name that must end here, or it could be the prefix of a data set. And you can also say where the matching must take place from. So this one, this one here says position 9. So it doesn't matter what came before it, so long as VAX FTP was started in the 9th column forward, then that would be a match. Okay. And you can say what should be about that special resource. So here we're saying that the resource that matches this dataset name will be made available. It doesn't have any lifetime activity on it. And if it did, it would be 60 minutes. That's a bit strange. But anyway, that's the sample. Don't take it as exactly like that. And the very last entry must be the last entry, so that the assembler macro that's building this knows that it's the last entry, puts the right information in there, so that it can tell. Oh, and continuation character. And what else have I got here? Other ways to hold and release jobs. We've got predecessor operations that do not actually run can be completed by some other process. So you can have put an operation into the plan that has a workstation definition that means it's not automatic, so possibly manual start and completion, or start and completion, whatever type it is. And then you can use the IzWS supplied program EQQ EVPGM to run an opstat to change the status of the operation. In the current plan, it can be either completed or put into error, depending on why you're running the opstat. EQQ EVPGM can also be used to change the status of a special resource. So you can change the availability or some other attribute of a special resource. And then, of course, with WAPL, you can run a WAPL process however you want to get your WAPL in there to change absolutely anything in the database or the current plan. Again, why you run it is down to your particular circumstances, but for sure you can really change how things process using WAPL. And ways to stop a job from being run immediately. You could put a manual hold on the job, and you can have the operators release it with a manual release. The manual hold can be set on the operation in the current plan or even in the database, so that when it comes in, it is already manually held. Or you could use a wait workstation. So this is a bit like the old transport time, but you could have a wait workstation that uses the duration time that you put on the operation to wait until it runs. So from the moment it goes ready, it starts waiting for the defined duration on the operation, and then it will complete. And that can be for very simple reasons. You know, you in the old days, it was like you were sending a tape from one data center to another. That's why transport time is also an alternative here, because it literally was for transporting stuff back and forth. And that is the conclusion of this presentation. This was presentation 6.0. Please leave feedback, and you can, as I said, unmute yourself if you wish to ask any sort of question, any question really. It's quite fine.
Oh, sorry, I couldn't unmute myself there, Anna, but I can now. You make these slides available, will you, Anna?
Yeah, they'll be added to the agenda. Look for the little man. I will be putting those up. I usually like to talk through it first, just to make sure that.
Oh yeah, no, absolutely.
But I think this one was okay.
There's a few interesting things, like we're trying to use conditional dependencies and whatever, but those, you know, the ones within a time limit actually are quite interesting, because we would have multiple trackers being sent back, and I'm just wondering, could we use that option as predecessors? Anyway, I'll have a look and I'll play about with it.
Yeah, so. I mean, there is, you know, there was the original ways to skin the cat.
Yeah.
And now there are many, many, many other ways to skin many cats. So,
yeah.
But definitely if you've got a function testing controller that you can go and play in, then that's great. You can do that.
Perfect. Thank you.
So hopefully there's something there that will help you.
Yep. No, that's good. Thank you.
Well,
welcome.
We've used, it's Neil Adamson. We've used what are called tracker jobs for years, where one TWS will submit a job via to the internal reader via, well, there'll be a step to submit something to the internal reader within a job across to the other system, which will just be a BR14. So we could, in theory, replace all of those with shadow jobs, I suspect.
You could, yes.
And
Then
we're
you
the
have the much
same,
more.
Neil. Yeah, I've been using tracking jobs. There's some sort of a concoction across two different controllers, and shadow jobs seems to be the way. And then also, sorry, Anna, the using shadow jobs. So you had said, set it up in the HTTP in the root ops or whatever, and then
Yeah.
have Z. If I was linking to a distributed, that would be D then, wouldn't it? Yeah.
I think it's a D, yeah. It tells
Yeah.
you in the root ops in the manual there. This
Yeah,
was kind
brilliant.
of like a brief overview of everything. And if you think of anything that I've missed, do let me know, because I can add it, obviously. But also, yeah, the best I think would be that if you were going to go to the shadow jobs, that you have a read of any tech notes that are out there. See if there are any. I should have a look at that, because I know some people have had issues with binding because the current plan extend times didn't match up very well, or for various things. And I know a lot of additional stuff has gone into it now, in the latest SPE for 10.2. So, if you're not on 10.2 yet, then you might want to think about it so that you can have the latest SPE, because it won't be on 10.1 because it's an SPE. It has to come to a certain level.
Yeah, that might be an idea first, because I have another Z controller and it has a different current plan build. And then I have a distributed controller that has a completely different, Historically, we have inherited these both. So, we didn't set them up.
Yeah.
But anyway, yeah.
And you never actually are sure that if you change the time of your current plan extend, what else you're going to break. So
Exactly. It's not worth it. It's not worth it.
So yes, it's worth having a look at that. And obviously you can't use a tracker job in this instance. I mean, you could be talking about something that's way over in some other country, or but because you can attach to it via HTTP, then
yeah.
Of course, I'm sure there's probably some sort of NJE method of getting the job over there, but yeah. For a tracker job.
I've also, we also very commonly have, when we're expecting a job from a third party, we have late alerting. So if a job arrives, more than a couple of hours beyond the expected time, then an incident is cut and the operators are told, etc. But
yeah,
we also get incidents, and I don't know why we've never done anything like this, where a job will arrive unexpectedly. Like we had one at the bank holiday weekend where the third party sent a job which we weren't expecting them to send on the bank holiday.
it was a bank holiday, exactly.
And it just occurred to me today, before this call, first thing this morning, why aren't we doing early alerting when things arrive unexpectedly? Just as easy.
Yeah, I don't know. It's a thought. Because obviously you can have a ETT or whatever, because that file arrived and you bring something in. So you shouldn't get caught out because the stuff you need to run comes in with it. But yeah, as you say, when it's not scheduled, maybe you don't even have that set up. You just pick up the file.
That's a good one, Neil. Like, as you say, on a bank holiday, if somebody sends you in a file that you're not expecting,
yeah,
can you alert them?
But you could, I mean, you could, of course, use ETT. So you could ETT in an application that just checks the file.
Yeah.
And if it's true that today is a bank holiday, you know, a piece of WAPL. If today is a bank holiday, then send an email or send an alert or do something to make people aware that it's happened. Yeah, because it's a special resource, but it's also can be in ETT.
Yeah. Yeah, as you say, there's so many different ways, and I just gonna skin the cat.
Yeah, you have to think.
Yeah.
And sometimes you've dealt with that type of thing in a particular way, and so you just go, you know, trundling off to that way without maybe investigating all the new things that you could do. So
Yeah, or something that's been there for 20 years, and you're kind of going, yeah, really, I should be going back and retrofitting all of this stuff and doing it using the new tools.
But then of course you go with the it's not broke, don't fix it.
Oh yeah, massive momentum for that.
Yeah, I think it is whether you've got time or whether it's just a small one, or you know you've tested it with some new ones and now you think that that does work and it's less hassle to set up. We can maybe move some of these others, but or if you're working, you've got to do a change in that application anyway. You know, that type of control around the change. But yeah.
Yeah. Okay, well, thanks, Anna. That was really interesting. Thank you.
Okay, that's good. I wasn't sure how useful it would be to those that have used IWS for a while, but yeah, I think it's the old adage, isn't it? You sort of notice that new things have occurred, but
Yeah.
you do things the way you've always done them. So yeah.
It's a good refresher of all because you generally don't pay attention day to day on a lot of these things. So shadow jobs I haven't really thought about very much at all, even though I knew they existed.
Yeah.
And it also, this would be useful for user education, for, pass this information on to our users.
Yeah, exactly.
But
Yeah.
and tell them which bits we would like them to use and which bits we really want to discourage them from using.
We haven't tested this yet, so don't use this
Yeah.
one, but yeah, this way will work. Yeah.
Okay. Thank you. Talk to you soon.
Nice chat, and
Thanks,
thank
Anna.
you for attending and caring enough to speak.